Zero sentindo questa cosa.
Hi everybody, how are you doing? Let me, hi. Close.
Ice cream right now? Yeah. I don't think they have much choice though.
Okay, so let's see. We'll start in a minute, okay? Okay, we'll go ahead and begin. Does anyone have any question before we start? Okay. So go ahead and go into screen share. We'll talk about wireless today, and then next week we'll talk about troubleshooting the networks, okay? So this week we're gonna cover wireless. You will find your assignment and lab located in Canvas. We also have a hands-on project. I chose for you to use an emulator to check or learn how to look at the information on your wireless router, okay? And we also have a 10-question quiz that's gonna be due next week. And next week is gonna be our last week in this networking course. Then we're gonna move into the security portion, which is the last class of your certificate. Yay, okay. So if you haven't downloaded the notes, you can check out the notes that's located here. And also download the assignment that's in the next page. Okay, so in this week, we're gonna talk about wireless LAN, which is WLAN. And wireless uses radio frequency, so the signal really pertains to line to side. Sometime your signal will be absorbed, sometime your signal will be reflected, and sometime you will get low signal because of your environment, your walls, if you have metal plates in the wall. If you're far away from the access point or the main source that's distributing the signal. Now, we know that every radio frequency type of device would generate some form of frequency in hertz. So if you have higher frequency, you can get higher data rate, but you can only generate it in a short distance. So for example, if you're using 5G at home, you know that 5G cannot generate in farther distance. So in the cellular network, what we see is that they would have to implement more towers and different technology to implement 5G so you can transfer at a higher rate. In addition, you have to have the device to accommodate that technology. So when people market 5G and you're using 4G device, you're not maximizing the capability of the technology. So here on the first page, you will find that it talks about frequency and data rates. So when you generate higher frequency, you will get higher data rates, but you can transmit at a lower distance. Okay. Now, most of your common devices at home, like smart devices, your smart TV, your smart watches, etc., a lot of the time they're designed to use 2.4 gigahertz frequency. Newer devices like your smartphone is capable of connecting at a higher rate, which is 5 gigahertz. Like we said, we cannot use it at a farther distance. In addition, you have other electronics that uses 2.4 gigahertz frequency, such as your microwave and other electronic appliances. Even the Bluetooth headphones, like the one I'm wearing, many of the radio frequency based device is generating or using 2.4 gigahertz, and we'll talk about that. So when you're using a lower frequency in a network, you can transmit at a greater distance. This is when you see public Wi-Fi for city, right? Like if you go to downtown Riverside, you will find they have public access point, or city of Loma Linda. In various cities, what they do is they offer public Wi-Fi access for their people. And you often see that with greater distance, because in a span of a city that's in larger distance, you will need to have lower frequency. Okay. Any question? Okay. So in the first question of your assignment, it asks you to explain the relationship between frequency and distance in wireless networks. We mentioned that when you use higher frequency, signal is transmitted in shorter distance. When we use lower frequency, signal is transmitted to a larger distance. So there is an indirect relationship between frequency and distance. Okay? So when you are implementing wireless network or wireless access point, for example, a warehouse, right? Because of the vicinity, the larger distance, we want to use a lower frequency. Any question? Okay, so let's talk about different bands. So these are the agencies that govern how wireless electronics or devices are using frequency and communication channels. So you have the IEEE, they're in charge of the standards. So with the standards, we're able to develop technology that will work across all different types of devices. And this is what you see worldwide. So IEEE, Institute of Electrical and Electronics Engineers, they are in charge of creating, testing, and operating the standards. So when you're using your wireless router at home and it's an AC, 802.11ac router, that is standardized by the IEEE. Then you often hear about FCC, Federal Communication Commission. They regulate the wireless devices in the United States, okay? And your wireless devices for consumer, we often think about our smart devices, our wireless router, but there are devices that would relate to government use, like warfare drones, how those communicate. Or sometimes you would deal with cell towers, how the cell towers generate signals. So FCC regulates our wireless technology in the United States. Then in Europe, we use the European Telecommunication Standards Institute, and they would produce the standards like what you see with IEEE. So when you go to a different part of the world, you would find that we would use different standards. Then you have Wi-Fi Alliance. This is the agency that makes sure that the standards in different parts of the world will work across internationally. So it promotes and tests wireless interoperability. And then you have WLANA. This is mainly to educate the awareness of wireless LAN. Okay, so these are the agency, and you would find the website located on page 1. So when we use wireless, FCC regulates it in different areas of the bands between 900 megahertz and 2.4 gigahertz. Most often you're gonna see consumer wireless is using 2.4 gigahertz bands. Okay. And this is referred to as ISM bands. So it's been established since 1990. And the way that we deploy the 2.4 gigahertz bands is mainly for the outdoor links, like I mentioned, when you go and find public Wi-Fi access point in a mesh network. And mesh network just means that it has different topology, different technology that's connected. Okay. Any question? And you can also find this in hospital, warehouses, and even homes, right? Some people, I use 2 bands. I use the 5 gigs and the 2.4. And most of us do that with the new wireless technology. So in the second question, it asks you, what type of facility is ISM band used? You will find them in office buildings, in homes, in healthcare facility like hospital and medical offices, and in warehouses. Now in hospital, they use wireless technology for various things, right? From emergency procedures, and on the X-ray scale, you would see a picture that shows where that frequency really lies. So you do have wireless technology that's used for patient purposes, and then you would have wireless technology that's using for office or business operation. Okay, so ISM is really referring to specific area of the band or the frequency. So often we would also use 5 gigahertz band, and this is called the Unlicensed National Information Infrastructure, the UNII band. And this is more on the recent years that we implement 5 gigahertz. We need the performance to transfer data at a higher rate. So you can find the answer for number 2 on the bottom of page 1. So here's the picture that I'm referring to. So when we're looking at sonar, like something that they would use to scan the ocean floor, that is at extremely low frequency. And this is safer when we use it with live creatures and life form. Okay. Then when you listen to the radio with broadcasts, you often see that that's at 900 megahertz. Okay. And then when we use cellular, like your cellular phone and also smartphones, you're operating at 2.4 gigahertz frequency. And then we're transitioning to the 5G, which is the 5 gigahertz band. So some of our smart devices are capable of doing that. Now the implementation of 5G is gradual, right? You hear a lot of advertisement with companies like AT&T, Verizon. So Verizon announced that at the end of this year, December 30th of 2020, they would fully implement their mobile network into the 5G. Even though they market 5G products like your new smartphones with Samsung and iPhone, their network is not fully adopted. So you do see customers are still using 4G with their 4G device. So to really fully transition to 5G, we have to make sure that our mobile devices are at 5G level, and they are all different. And then you have some infrared technology here. And the infrared is when if the technology that you can reference for this is when you have heat sensor, like now a lot of people are using the wireless hand scan to scan people temperature for illness because of COVID-19, that uses infrared. It tracks heat sensor. Or when they have heat sensor camera to detect motion, that's infrared. Then you have X-ray technology that's used for medical purposes, that's on the higher frequency range. And because, all of these use some form of radiation, right? It's radio wave. There's some minor impact, and there's a lot of research about radiation with radio frequency. Now on the higher scale, like X-ray, that's in high range of radiation, and that would impact health. So wireless technology, as we see, is abundant, but it's using different band, we're able to implement different technology. Any question? So it mentioned that you would see 60 gigahertz band that's used in the newer standard. Right now, we're at 802.11ac standard, which is often found in homes and in some form of communication. But with the study for the 802.11ad, which is very high speed and very short range, as you can see, the frequency is a lot higher than what we see with 5 gigahertz. It's 60 gigahertz. So that is to come. Okay. So in this picture, it also gives you the history of wireless technology. When it was drafted, when it started to be implemented. So in the mid 1990s is when you start seeing the use of wireless with the 802.11 standard. And for the early 2000s, we started looking at better transfer rate, better technology with security. So you start seeing some of that transitioning in the early 2000s. Okay, so this gives you a brief history of wireless. Let's talk about cellular network. Let me see if I can. Okay, so before we answer the next question, let's talk about cellular network. So in the olden days, right, I want to say more than 15 years ago, you would see Global System Mobile, which is GSM, and the companies that we see in the United States that's really heading this type of cellular technology is AT&T and transition to T-Mobile. And this technology uses subscriber identity module, which is the SIM chip. So the old cell phone that uses SIM, right, and some of the newer cell phone uses SIM, and that transition to a different type of network that you would see that would use GSM. And this is like the 2G to 3G era. So we're looking at least 15 years ago that was implemented. Okay. And then there was new development in different areas. So you have the FDMA, which is a modulation for cellular network. And this is an older technology. So that was 1 gigahertz. That's how fast, you know, the data was transferred. Your TDMA uses different channels division for calls. So in the case where when people were making voice call in a cellular network, this gives us the increase in the communication using slotted time with the channel. And that's how they used to charge airtime back then, when by the minutes, right? Because it's dedicating specific channels for calls. And this reduces eavesdropping, where people can tap into the line and listening in on voice conversation. So TDMA was implemented for security reasons as well, because it's using multiple channels for that slotted time. Then currently, if you are using Verizon network, you're using code division multiple access. This uses a unique code for each call or each data transmission. And it would spread across a range of frequency. So it's not dedicated to one specific. So this is why when you transfer data, you would see different rate at different time if you do test your connection. And CDMA would be fully implemented to the 5G, right, with Verizon at the end of this year in 2 months. Then if you're using T-Mobile, other type of network, you often see, and Verizon did carry some LTE, you would see long-term evolution which is LTE, and it would utilize a specific type of device connecting on an old transition GSM network. So because AT&T, T-Mobile had implemented GSM, they have to find a way to upgrade the cellular network to a better transfer rate. So they implemented LTE following GSM or Edge. Okay. So back then, right, if people were using, I want to say at least 5 years ago, when people were using the 3G going to 4G network, you would see that it would say Edge or GSM. Now it would say that you are on LTE. And this is the 4G, okay, when you see LTE. Now LTE also have 5G implementation, and that's transitioning. So in the next few years, you would see full adoption of 5G with LTE. Okay, so like I said, different technology would require different type of devices. So if you buy a 5G phone, then you can use it with the 5G cellular network. If you have your old mobile phone, like an old iPhone, or in my case, an older Samsung phone, you will not be able to capitalize on the 5G network. Therefore, and also it's not everywhere in California. It's still being implemented. So a lot of the marketing is really, to get the customer to transition to 5G. So here, what you have is the next question. What type of cellular network is used for 5G? So we see that code division multiple access, your CDMA, is used for 5G. And long-term evolution, and it will say LTE 5 or 5G. That is also used to upgrade to 5G. Okay, so now the next time that you are looking at mobile packages, right, like buying a new smartphone and selecting your provider, you can understand, at least on the terminology level, what these are. Any question? Okay, so the answer for 3 is there, CDMA and LTE. So let's go specific into 802.11 standards. So when we started out years ago, data was transferring at a very low speed, even though we're using that band. In 1997 through 1999 is when we started to see rapid movement or change in the standards. So this is when you start seeing company implementing more wireless networks, right, using the old 802.11a and b. So back then, in the 1990s, wireless networks, the devices are computers are transferring at 54 megabit per second at top. But already we're using 5 gigahertz frequency. So when 802.11a came out, that was very fast for many companies and many people. The downside of this is that because we are using 5G for 802.11a, we can only implement it in shorter distance, and there were issues with security with the wireless. Then 802.11b started to develop. Even though it was transferring at a lower rate, we're able to go further distance with 802.11b using 2.4 gigahertz. And also we started developing various overlapping channel where we can connect access point to access point. So we can span it into a larger space in a vicinity. Okay. And then to upgrade from 802.11b, we transition to 802.11g, transferring at 54 megabit per second, which is higher rate than B, and operating at lower frequency band, 2.4 gigahertz. This is when you started to see more popularity for home use with wireless networks and more capability to buy wireless devices. And we also upgraded the security encryption, the cryptography for wireless networks. And then the most recent one before your current standard is the 802.11n. This allows us to use what's called Memo antenna. So in a wireless router, sometimes it will come with, let's say, 4 antennas. 2 of those will be used for input and 2 of those will be used for output. That allows us to improve transfer rate and also signal receiving and sending. So in 802.11n, you started seeing routers that would have more antennas and devices that would have different type of antennas. Okay. There are some that I don't mention because it was not fully implemented for commercial use or consumer use. There were some that were used for government testing purposes and government-based transmission. So we often see that it's either for industrial or government use. Okay, and then going back up a little bit, you see the 802.11ac is what you're using now. And we can operate on a dual band, and we transfer at 1 gigabit per second, which is way faster than how we started. So it asks you for question 4, which wireless IEEE 802.11 standard has transfer rate of maximum at 11 megabit per second? And it was widely adopted. That was 802.11b. And B was lower, but we were able to use, like I said, lower band frequency. So that was why it was so widely adopted. Now, the one that's backward compatible with B is the following standard, which is the 802.11g. So for question 5, it asks you which wireless IEEE 802.11 standard has transfer rate of 54 megabit per second, and it is backward compatible with 802.11b. That will be your 802.11g. So G was designed to work with the older devices and to be adopted with the older networks. So what does this mean? I can have a router that's 802.11g, and I can have a computer that has wireless adapter using 802.11b. So my computer, since it's using the older standard, it's only going to transfer to the older standard rate. So with this wireless network, you would have a mixed different technology because there's backward compatibility. But your device, depending on the standard, it's going to transfer at that rate. So
Question?
to speed up my transfer, then I would have to upgrade my wireless adapter to 802.11g. Question?
Yes, what can you tell on the device what the standard is?
So often that it's already installed, you have to read the documentation. For example, like the laptop, you have to refer to the manufacturer website. For the motherboard, which has integrated wireless adapter, right? But when you purchase the device, right, like this one, this is a Tenda wireless router. This is the newer one. It will tell you usually on the actual model number or in the description of the device.
Oh no,
Now you,
I meant like your computer, not the router.
yeah, so your computer, you would have to, it doesn't say the actual standard, it will just say 802.11. So you have to refer to the manufacturer that produced the wireless adapter or your, your motherboard manufacturer.
Okay. I thought you
Yeah.
could look it up somewhere on like the devices.
Because if you look at device manager, right, I'm going to show you that right now. In Windows, you have device manager to look at your adapters and all your hardware. Okay. So sometimes manufacturer, like the one I have, it will tell you that with the model number. That's the standard way now for the newer technology, is to specify the adapter standard with the model number. But it's not always the case in the older technology. So I want you to keep that in mind. So in my case, I'm using AC on my laptop, right? So it would say AC. And that's a quick way that you can look at that.
Thank you.
Okay, you're welcome. Let me see if system information will give you that as well. Okay, so a console that you can use in Windows is called system information. This is integrated since Windows 7. I think this one usually just tells you more. Let me see if I can find it. Yeah, so under network, you might find some information. So when you see 802.3, that's for Ethernet. That's would be my Ethernet adapter. Let me see if it would give me some additional information about my Wi-Fi on here. Yeah, I don't think system information will give you much more, except for you do get a little bit of information about the protocol under the network adapter. And it would tell you, the capability of that adapter with the type of protocol. So in this case, it's referring to Ethernet in general. And it shows TCP, IP, and UDP. But yeah, so I would say the best way on the user end is to go through Device Manager. Okay, and then you can simply select your adapter, your network adapter. Okay, so I also have Bluetooth integrated on this system. So, and it would show that here. Any question? Okay, so for 4, we put down 802.11b. For 5, we put down 802.11g as in Gary. Okay, those are the common consumer standards. So this little table gives you a little bit more information about all the other. So if you're curious about all the other standards, it lists that. Okay. All right. So one of the things that would come up on Network Plus certification or other type of networking certification, they will ask you about carrier sense multiple access with collision avoidance. That's called CSMACA. Okay. This is a way that we would use the data link layer for the data frame to prevent data collision, meaning that it would send some kind of request and the receiver would acknowledge, so it would respond back with the CTS. So that way packets, which is your data is framed into packets, can be received and sent appropriately between your access point and your system. Okay, so just to sum it up, it's a way of acknowledging what is being sent, who's sending it, and it would look like this. So first, the system would submit a request to the access point or to the destination. The router or the access point would say, I'm ready. Then it's going to send a CTS. Then data is going to transmit. Once it receives the packets, it's going to say, I got it, sends an acknowledgement back. So this is a way that we can make sure that the data would be received by another host. Okay? Okay, so on page 4, it talks about 802.11g, information about how it upgraded from B. Let's talk about channel real quick. So these are the channels in the 2.4 gigahertz. And when you configure your router at home, you're wondering what they are, right? You would see 1, 6, or 11. Okay. In some type of router, you would also see the others. Or usually they would tie to frequency and channel. So in United States, under the 2.4 gigahertz band, we are allowed 11 channels, okay, that are configurable. Channel 1, 6, and 11 are used for overlapping. What does that mean? When we have overlapping is when you're looking at a network, let's say a hospital network, you would have multiple access points. And each of those access points is part of the same network. So they would each use a separate channel that's overlapping to operate on that same frequency. So when you have multiple, like 3 access points in the same area, you need to configure the first one with channel 1, then the next one with channel 6, and the next one with channel 11. When you have 6, the other ones, so the one, how you physically install them is important, because the overlapping channel allows you to bridge that signal across the facility, such that it is such a big hospital. You gotta make sure that that signal is not just repeating, but it's communicating within that network. So you again repeat some of the overlapping channel throughout the rest of the facility. Okay, you will see a picture at the end that shows that. Okay, so you don't use the same overlapping channel for all of them. That's going to create problem. It's going to create interference. It's going to create issue. Everybody's on the same channel. That creates a lot of noise. Okay? Any question? Okay, so in the next question, question 6. How many channels are configurable in the United States? And what are they? There are 11 configurable channels. Okay. Some are overlapping, so we know that the overlapping is 1, 6, and 11. Okay. So you would often see that we can use, this should be 2, I'm sorry. The other ones, you can dedicate those, right? 2 through 5, 7 through 10, and 12 to 16, those are not overlapping. So you can actually set up where specific devices would use a dedicated channel in that band. Let's say that I have one department that deals with essential medical information. I can have that all the nurses, the doctors, and that's using their laptops and their tablets. I can configure that specific access point to utilize a certain channel just for that department. Now, when you do that, what will happen is that it's not gonna be on the same channel as the other ones that are overlapping, which is 1, 6, and 11. Okay, so with the later technology now that we can actually have non-overlapping channel dedicated, and then in some router it's designed to only work with other access point and other systems, so it uses overlapping channel. So when you do your project this week, I'm having you use an emulator for a certain wireless router. You will see this information being displayed. Okay, any question? Okay, so in question 7, it asks you, Teresa configures an access point to use channel 1 in a building. If she needs to add another access point to the same building, what channel could she use in IEEE 802.11g standard? She can use 11 or 6. But if you use 11, it will be the farthest from channel 1. Okay? So she can use channel 6, but if she chooses to use channel 11, it will be the farthest from channel 1. And that would be my recommended option. Any question? Now, if you're considering taking Cisco certification, because Cisco produce also their own wireless appliances like Linksys, they bought Linksys years ago. And then they have their own technology with antennas and such. So Cisco have specific technology that they ask question of, compared to Network Plus, where you would have more of the general standard questions that would use across many different devices. Okay. Many networks implemented Cisco technology, but not all network uses Cisco technology. Okay. Any question on number 6 or 7? Okay, so going back to the old 802.11a, it was ratified 2 years after wireless really came out or released by IEEE. And it changed over time. It was very expensive. So in 2001, they were able to get it to be 54 megabit per second, because in the olden days, it was still very slow. So by 2001, you would see that it was operating at 54 megabit per second using 12 non-overlapping channels. And the way it was designed, it was more difficult for manufacturer to develop massively. So it drove up the price on the technology back then. Okay. Also, look at the band, right? We're using higher band. So this is an important statement to pay attention to. Like I said, operating at 5 gigahertz radio band, 802.11a is immune to other devices that are operating at 2.4 gigahertz, like your microwave ovens, your cordless phone, your Bluetooth devices, and other wireless technologies. So when you go to a business like Target, they use a lot of wireless technology, from the hand scan that you see that they use at sales terminal or to do inventory, right? All the way to, you know, the communication. Also could be handheld products that would check for shipment that comes in. So you see a lot of the wireless technology that's mostly operating at 2.4 gigahertz in businesses. So when 802.11a fully adopted at 54 megabit per second, it was very pricey. So when we started with that standard, if you look through this list right here, right, you have 9 megabit per second, 12, then transition to 18, and gradually we got it up to 54. And then after that, we just implemented other standards that would be equivalent or better. Okay, A was not compatible with a lot of later standards because it has specific channel and frequency use. Only 802.11n actually had backward capability with A. Okay. Here's a little bit on the H. It was not fully adopted for consumer use, but it also used to 5 gigahertz frequency. It has more channel, non-overlapping channel, and it uses DFS and TPC. So it allows you to have frequency selection in range, And originally they wanted to upgrade the A to H, but it was not fully adopted by many vendors. Okay. The cool thing about this one is it has the capability to manage power. So in industrial use, that's very important. Especially if you're looking at like manufacturing areas where wireless needs to be implemented. This allows you to control and reduce, it changes the power usage, how it transmitted, because when we transmit signal, we need power throughput. Okay. So that was a way that we can implement energy efficient for wireless. Okay, I touch a little bit on Memo, right? Some people call it MIMO, but it's referred to as Memo, multiple input and multiple output. This was adopted since 802.11n. These are called smart antennas. Okay. So usually when you have 4, you would have 2 for receiving and 2 for sending simultaneously. Instead of relying on 1 antenna, when you have 4 antennas or 3 antennas, sometimes they come with 3 odd number, but usually you would see even number. Then it would be better, because each antenna uses different path to optimize, and that prevents resistance. So this is what we call the spatial multiplexing. In 802.11n, you also have what's called channel bonding, where you can have both 2.4 and 5 gigahertz. And this is what you see in the current AC, was that they took 802.11n that worked, the feature that worked best with that standard, and they upgraded to the next one. So your AC is not that far from 802.11n, which is the prior standard, the one right before it. Okay. Now, if you want to use 802.11a G with the N, you have to use the 20 megahertz channel. So when you do your hands-on project this week, when you're able to look at the channel hertz setting, you can understand why. So if we lower it, we can use it with the older standard. If you increase it, if you raise it up, you select the higher one, it can only use with the later technology. Okay, that means that each of the channel can utilize that much frequency. Some of the things that were implemented for security and accuracy of data was what they call MAC efficiency protocol. This allows it to acknowledge each of the data frame, kind of like the old way that we can do the CSA. But instead of acknowledging every single time, it's gonna wait for a whole block, because data is sent in pieces with the frame. So when it receives the whole block, then it's gonna send the acknowledgement, which is way more efficient compared to the old standard. Okay, so that was a cool thing that they implemented, just to highlight for you. Any question? Okay, so going back to dynamic frequency selection, this is a way that we can prevent interference that occurs on our wireless because there are many electronic devices or system or appliances that's using the same frequency, 2.4. So DFS allows us to avoid interference that occurs in that band. And you saw your cordless phone is at 2.4 gigahertz. Microwave oven is at 2.4 gigahertz. So when you have a lot of different electronics together in the same space, you often see that there's interference. It would have degrading signal, or sometime prevention of signal being received or transmit. So this is why when you physically station your smart TV and your phone and different things in a room, you should think about this, okay? And with the transmit power control, it enables the client to use less power. It would have enough energy for the connection to the access point, so it reduces power through battery. And when you're looking at industrial use, they don't necessarily connect all their access point to a power line. You often see that it would use some kind of solar plate to charge the battery. And once the battery is used, right, the solar would continue to charge it. And when you drive around downtown, like Riverside, look up at, you know, different light poles, you would see them. They don't necessarily have the antenna sticking out, but they have a built-in antenna, right? So their antenna is not just sticking out from the side. Sometimes they do. They have built-in antenna that's already incorporated in this box, and it's weatherproof. Because if you have antenna sticking out, people might tamper it, it might cause corrosion. So in some of these boxes, what they do is they have antenna that's incorporated inside the housing of the actual component. So with those, it would be better to implement transmit power control. Okay. And with Memo, Memo is known for multiple transmit and receiving antennas. So you have higher data throughput. Okay. Any question on 8, 9, and 10?
Can you make your own antenna and then somehow add it to your existing configuration to have a Memo?
The Memo technology is actually also incorporated with the router board. So even if you can buy a Memo antenna, it's not always adaptable to that router, because the router has specific instructions to understand certain signal. So yeah, I do see that there are Memo antenna that you can use in case of replacement, but in order to really make sure that that router is, or access point understand Memo, is the firmware too. So even if you attach and connect it, and it has to have a way to connect, you have to make sure that your router firmware is able to adapt to Memo. So usually the later of 802.11n router or later, you would have Memo. Anything prior to that, no. okay? Like for example, I have a Tenda one. I bought this for my CIS824B class. And I bought a bunch of them for use in class. So what you see here is it has 4, and you might have something like this at home, okay? So 2 would be dedicated for send and 2 is for receive. And on the box itself, it will tell you, or in the description of the router if you're looking at it online, right? But usually on the box, it will tell you. Now, they would also advertise your Wi-Fi devices, wireless devices with a sticker. It would say Wi-Fi, right? Often you would see this on appliance or even like adapters. So Wi-Fi stands for wireless fidelity, and it would work with the standards that it would specify, like AC, okay? So for the AC is operating at 5 gigahertz. So all that sticker really tells you is that the products had been through standardization, and not all vendors would have them tested and go through the approval for that. You would see on shelves at the store or online that not all of them would have the Wi-Fi sticker, because sometimes companies won't spend time and money to have it go through and the Wi-Fi Alliance to really test it for interoperability. They have internal testing when they produce that product, and then they will put it out in the market. So not all wireless devices would have Wi-Fi sticker. And if it does, it just means that, you know, it's been through the compliant process.
So have you seen those devices without the Wi-Fi sticker? And
Oh
how
yeah,
do they
plenty.
and are they still like up to standard, or they're
Yeah. So they adapted the IEEE standards, which works across with other devices. Like this one doesn't have the Wi-Fi sticker. The Tenda router that I have, it was like $30 or something like that. So I was able to get like 20 something for my students, because the school, they didn't have we couldn't get the funding to fund fast enough to get that for my class. But yeah, so you see wireless adapter being sold that way. You see wireless router being sold that way. The larger companies like Cisco and, you know, the ones that have been doing it for a long time, yeah, they would have the resource to put it through. But when you see some of the newer companies, or if they're selling new devices, they don't necessarily put it through compliant. It still works. It's just that it's not having that label or recognized by Wi-Fi Alliance that it has backward compatibility. They test it internally before they sell it, right? And you have warranty with that, so you can always return it.
With that wireless router, does that serve as an extension of your router, or would it to replace it?
Yeah, so this one doesn't have the modem capability, meaning that it doesn't have the coaxial connection or other, you know. So your router at home that you get from the service provider, it has a way to connect to the line out, which is your you know, your coaxial line, or if you have fiber, that's a plus, right? Usually they use coaxial. So on this one, what you have is you only have a power connection You only have the internal Ethernet connection, and that's it. So the difference between the one that the service provider provides is that they would have a coaxial connection for the line out. So yes, you can use this one as an extension to your network, right? But we can use this for business network as setting up multiple as an access point because it has AP capability. Okay.
So it wouldn't work like the Google Nest, how it's like kind of an intensifier for the Wi-Fi?
How do you connect your Google Nest?
Well, the Nest, it has like a central hub, and then you buy kind of like extenders where you put them around the house, so it kind of creates another, I guess, like,
Yeah, sub network.
okay, yeah.
Like an ad hoc network. Yeah. No, it cannot replace the Nest if that's your question, but it will work as just extension. So in this would work really well in like a small business environment. If you need to have like different access point for your employees, that will work really well for that. So yeah, it's only like an extension to an existing network. That's why it's so cheap. But when you buy something like with the Netgear that has the modem capability, which is that it would have connect out, then yeah, that will work. Okay. So that's why you see different grade and different prices with a lot of these Wi-Fi. So yeah, this one, I think it was really easy to configure. It came with an app, and then it has like, you know, information on it that you would not get lost installing. So my students, they like it that they were able to configure it. It has capability, all the capability with AC. It just doesn't have some of the modem capability. Okay. Okay, so for 11, Carlos bought a new router that's the route and found a Wi-Fi sticker on the box. What does the sticker imply? That it has passed certification testing for 802.11 interoperability by Wi-Fi Alliance. This is non-profit, and they just want to ensure that it's capable of working with the older 802.11a, b, g, and n devices. So you now understand why there's a Wi-Fi sticker on the package. And your current AC transfer rate is at 1 gigabit per second at most. So we might be transferring a little bit less depending on many factors. How many devices are on your network? Right? What is the line to site? Meaning that how far you are from the access point or the router. Are there walls in between? Are there any other interferences with other electronic devices? If you're using 5G, right, are there any other 5G devices on that? So you have to consider other things. And when you have more than 100 devices on that network, which we don't often have at home, we have between 10, 20, 30 at the most, right? You would get a lot of noise and your signal would degrade. So this is why when you're looking to design a business network, you have to take a look at their scope, what kind of data that they're using or they're transferring, how many the devices are going to be on that wireless network, how the physical layout of the building so you can install proper access point, and we'll talk about site survey down the line. Okay? Any question? Okay. So for number 13, it asks you, Paula wants to upgrade her wireless network speed. She purchased a new 802.11ac wireless router. In her home network, she's using 2 laptops that have 802.11n wireless adapter. What is Paula's system maximum transfer rate? How can she improve the transfer rate in her wireless network? So the maximum transfer rate for the laptop themselves, because they are 802.11n, it's going to be 300 megabit per second at the most. If the laptop has an adapter that has the antenna, it might go up to 450, but often you would see it's right under 4, about 300 megabit per second. So to upgrade the network transfer rate, she would need to upgrade the wireless adapter to AC. And you can buy, you know, USB ones now with the antenna for AC. Okay. So the marketed speed is often the maximum, the optimal speed. And we don't always have optimal speed. Okay. So because her laptop is using 802.11n, it's going to be doing its best to transfer the data, even though she has the newer router that's able to have throughput at 100 gigabit per second. Okay, so upgrading your router doesn't always mean that you have top speed. Okay, there are other things, like I said. What type of devices do you have? Okay. Yes. Sarah asked if Google had specified that it's a mesh. Yes. Okay, so you would see a similar question on our quiz. This kind of give you the information on how to upgrade or increase your network speed with hardware. Okay. For number 14, it says Max's office is 200 feet from the company's 802.11g access point. Why is Max laptop transfer rate 15 megabit per second, which is much lower than the rated transfer speed? So because it's at 200 feet away from the access point, we have degrading transmitting signal due to distance. So when we do site survey in a company, we want to make sure that we check our signal, right, and install overlapping access points, so that way the user would always have strong signal even far from, you know, the main access point. So it's repeating that signal. So that simply is because it's distance. And when you have facility that has multiple floors, you gotta have different access point, right? Because signal doesn't go across floors. So you have to have, let's say you have an office building that has 4 floors, right? On each one, you would have at least 2 AP. And all of those AP connect back to the switch. And that switch connects back to, back to the rack, which is an uplink switch. And that switch would connect to the main router. On a small scale of a business, let's say like a retail store, right, you would also have many different access points depending on how large or small. So when you're looking at something like Costco, right, for their employees, they have to have multiple access points. I would want to say at least 4 for how big their warehouse is. And they can have one in the middle and then some station throughout near the corner, so that way it's overlapping. And then also they have the back area where they have receiving and shipping area. That area also need to have access point, because you have shipping trucks that comes in and we need to scan products for inventory before they get put on crate to supply the shelves and the area of the warehouse. So in such sense, what we have to do is we have to consider the distance, right, for the vicinity. Okay. So it talks about AC here on page 6, where it uses the wide channel. You can also use the wide channel on the lower frequency to work with the older standard. Here is a picture that gives you the understanding of how distance work across different standard. Okay. So if we're using 802.11g, when we're about 200 feet away from it, you get approximately under 20, maybe 12 to 15 or 10 to 15 megabit per second. And then as you get farther, right, there's no interference or wall, then you also see that it's about under 10 megabit per second. With the A, since it's in a higher band, right, you get higher speed, but approximately 50 to 70 feet away from access point. Okay. And many of the newer routers has a signal amplifier or repeater, so that way it would take the transmitting signal and it would increase it, and it's to be able to send it to further range. But it doesn't always mean that we don't need extender or AP throughout our larger warehouse. Okay. So the last question we answer, you can also refer to the picture. You see that distance have an impact. All right, so let's talk about your network devices. So your wireless access point, also referred to as AP, they would look like this. This is a Linksys picture. There are many different types of access point. Some already have a built-in antenna. You might not even see the antenna on the outside like this. Okay. You would also see industrial access point, which can be used for outdoor. Like I mentioned about downtown, certain city, you would see those. And sometimes it's battery operated. Sometimes that will have solar charged battery. That's a better way to use, you know, to use our energy and be able to supply the energy using solar. Here's a wireless adapter. So to really construct a wireless network, you just need to make sure that your device have capability to communicate using a wireless network interface card, right? If it's a laptop, it likely would have a built-in, or a tablet would have a built-in. Your smartphone has a built-in. And if you're looking for wireless adapter, consider the type of antenna it's using. And then you just have to have access point, which is wireless. So those are the two main components. Okay. So when I started teaching networking back in the day, right, wireless implementation was not that common. Then, you know, transition over time, even so, we don't always have complete wireless network outside of home. Okay, you do see companies that use a lot of wireless technology, but you know that your LAN, your Ethernet connection is way faster, right? In most cases. So this is why most companies don't fully go wireless. You would have like wireless for, you know, visitor area or some public use, but the main network is still wired network. So in a wireless network, what type of device is connecting all components together? That will be your AP, your access point. And sometimes they are referred to as WAP, your WAP, your wireless access point. Any question? So let's talk about antennas. Okay, so we talked about how Memo is a type of antenna that sends and receives simultaneously, but there are also antenna that is for specific direction. You would have omni antenna that's going to go from point to multi-point, and you would often see this on wireless router and access point. Okay, so it uses the same amount of power for all the directions at the same time, and antenna requires power. This is why if you see how in some area when people are trying to use TV antenna, right, they put up the Yagi antenna, that's what it's called, they would have some kind of power distribution to it. Or when you buy like an antenna for your TV at home, like it looks like a square plate, or even with, you know, like an actual antenna sticking out, you still have to supply it power, because without power it doesn't work. So going back to Michelle's question earlier, right, can you buy an antenna and attach it to the device? Yes, if you can, if it's attachable. If it's not, you have to find a way to supply its power resources. And also that device needs to understand that there's also it needs to receive signal from that antenna and send signal from that antenna. So with the Omni, it's dispersed to many devices, right? And that's why it's implemented in your access point or your wireless router. So most of the time we would see AP using Omnis. And when do we really use device that has Omni? When that access point can send to any direction. So at home, that's usually the case. You can be upstairs, downstairs, you know, in the corner of the room, in different rooms, and you can still use it because it has omnidirectional antenna. With the Yagi, it's going to be point to point. They often use this type of antenna to connect an access point with another access point. It directly to that next system. And it was also used for television. Like back in the day, people still use this, they would have one that's attached to the roof. So in the industrial application, the Yagi actually is used to send signal to the next access point. And sometimes they would install this at a light pole or in specific location. And it's pretty discreet because the practice is the physical security where you don't want people to tamper with it, right? Okay. Question? I see some things in the chat. You have a problem with the screen? Is it blurry? Maybe check your video configuration.
Yeah, that's always nice. It's like kind of jittery, so I'll look at that.
Okay. All right. Try to see if we can troubleshoot that. So for 16, what type of antenna is used in access point? That will be your omni antenna, because it needs to send signal to all different devices in all different directions. And to connect two access point together, we call that bridging. That will be your Yagi antenna.
I have a question.
Yes, Michelle.
So I've set up my devices with for Wi-Fi, and I guess I get suspicious when I'm prompted for the password again for the router, and I don't know if that's like an evil twin rogue AP thing, because I don't understand why it would prompt for a password again when I already put in a password for the Wi-Fi for the router. Because I know that they can, you know, the hackers can make it so that they it has the same exact name as your network, and so that's how they steal your password for your Wi-Fi.
Mm-hmm. So explain to me, when you get prompted with this, when does it happen?
Like if I turn on my device again, I might get prompted for the password again. And I know I already
like your pre-share key, your PSK, you mean, right? Like the security password.
Yes,
okay.
For the router.
Yeah. Okay. Yeah. So because when I hear password, I thought about like to log into the router for configuration, but just to add yourself to that network. Okay.
Yes.
So the explanation for that, right? It could be a threat, but it's not always a threat. Okay. The reason why it's prompting you for the pre-share key again, for the security key again, is that sometimes when we shut down our device and we turn it on, when you configure your device is not always connected, also your device get a new IP address coming from your wireless router frequently. It's supposed to do that, at least is the address, every now and then, right? Sometimes 7 days, sometimes longer. It depends on the setting. And also, many of the devices also have that feature, in that it, even if it stores that pre-share key, it would do that so that way it would update for security reasons. Now, yes, you're right. There's a way that we can use an evil twin, for example, using Pineapple to make it a fake router and get the user to input information and then take over the device. A quick way that you can check is to look at your wireless router. You can type in its default IP address, like 192.168.0.1, or sometime like Cisco devices, they use like one, a 54 or another number. Once you authenticate it as an admin, there's on the newer router, you're able to map. You would see a network map. And as the device, the router, it advertises itself to all of these devices. It says, I'm here, connect to me. But it also sends other devices in the vicinity. So in order for them to do evil twin, that system also needs to advertise itself to your router. Okay? So we would be able to see, and it might show up as an unknown device. It might show up as some kind of name that they would use it. So that's a way to look at it. And if you know how to use network scanner like Wireshark or OmniPeak, etc., you can scan and it would see it.
So
because,
it wouldn't, I'm
yes.
sorry. So it wouldn't be the case where I would see two routers with the exact same name?
Before they take over your router, they have to get you to give them information to connect to your router. And that would be the first step. So, and then it would mimic your router. Yes. So sometimes they need to get more information to make it your router. Okay. And then once they impersonate your router, then they would get you to connect to them, and then they would shut down the other router, and that's how evil twin attack occurs. But your router would see it, because antennas, electronic signal wise, it sends it and it receives it. There's no way that their system can detect yours without sending electrical signal. That's why I tell my student, Wi-Fi hacking, it always calls home. Okay, a lot of these things always call back to the host. So there's no way to do it stealthily. They have to make it fast, and they have to make it believable, but it doesn't always mean that you can't detect it. So a quick way to check is to look at your network map if you don't know how to use a network scanner. But if you know how to use a network scanner, use a wireless device and scan, like your laptop. Run Wireshark and it will tell you every system on the network at that moment in time. You just need to run it for a few minutes, just pause it, and then look at every single address. And that's what we do in security and networking. So I'll see in the next lab or the next exercise if we can do that in class when we troubleshoot. Okay. So I don't know if you guys know, so here's to throw in real quick. We'll come back to this in 802, in 824C. But a way that they do evil twin, to sidetrack real quick, is they use a Wi-Fi pineapple or something similar. People can buy this online. It looks like a wireless router. It comes with the manual. It's not, if you don't know networking and security, it can be very difficult to use, but you can learn it. So you have to run Linux terminal. It uses Linux in the back. So here's a picture of it. They attach a screen to it. So somebody can literally sit in the car and scan your network and impersonate your router and take over your network this way. And then and they come with antenna as well, as you can see. So it's usually always sell out in a lot of different websites, right? Hack5 was the first one that produced these in carry. So this is the Tetra. Oh my gosh, they raised the price so much, but I think they're just sold out, so they put the price this way. But Hack5, and normally you would see them about $100, $200. I have a couple of these for security classes, but you can also find other type of products. This is designed to teach cybersecurity. Okay, so you see how many antenna these have as we talk about their omnidirection antenna, and it can be USB powered too. Okay, and so they have all different type of devices here. Okay, and we'll talk more about these when we talk about security in the next class. And that is what people would use for evil twin attack, which is to make this an evil twin to your router. Okay. Any question relating to antennas? Okay, so when you install a network, simply we would need our wireless access point and our wireless devices. You would have two type of mode. So ad hoc is more on where no one really controls, and this is what you would see in a home environment. A lot of the time you would use a pre-shared key, your PSK, like that security phrase that you have, right? That long key phrase that, you know, it's on your router sticker, and if you change it, it's stored on the wireless router or access point. So as you have established a connection with the configuration, that key is stored on that device. So the key is being exchanged every time that that device is connected. In Michelle's case, she said, why is that sometimes I have to re-input that, right? Possible that sometimes your device it had updates and it's installed updates, and that cache information is gone, right? And also on a lot of different OSs, they implement this as a feature where you have to occasionally put in your key, even though you're connecting into the same network, okay? And as it updated with different addresses, it might see it as a different connection point. So yes, there are times that you still have to update your key. And if you want to be safe, right, look at your network and see who's on it. If you see an unknown device, kick it off, remove it, right? Change your key. So that's one way that you can also check. And we should always update our security login information anyway. So this is the easiest way to connect all your devices wirelessly. And it uses what's called Independent Basic Service Set, your IBSS. And I know the Network Plus certification asks about this. Okay. So what that will do is it allows two or more devices to communicate, and it establishes the service communication for those devices, like your laptop and your router. And there's no hierarchy in this. Usually you just connect. You can have a computer to a computer. You can have, you know, a system, a tablet to a computer. So a ad hoc is really a way that we can communicate between the devices. So with this, you would see a picture of that. Okay. Well, my husband, he sometimes uses his smartphone. He uses the iPhone, and he uses AirPlay to watch some kind of video on the TV with it. And that's what you would see using AirPlay, is just a service that we would have it set up where the phone and the smart TV communicate. And then that way it's really establishing an ad hoc communication mode. Okay?
I guess that would be easier than to use the iPhone HDMI adapter.
Yes. Yeah, so many of these manufacturers, they offer a way to use NFC, right, or wireless communication. So AirPlay is Apple, and then Samsung has their own, or other manufacturers have their own. Yeah, so you don't have to attach the adapter and connect it. You can just use it wirelessly. Okay. So in the infrastructure mode, and you often see this for business use, it uses the basic service set. So the other one is IBSS, this one is BSS. And it's a way that we can have all hosts connecting to the access point. Now, when you set it with the authentication, if you set it for infrastructure mode authentication, with WPA2, what you will see is that it's going to require individual login instead of a pre-share key. So when we say pre-share key, what do we mean? We're using the same key, right? That's for everybody. And you should use WPA2 or better, okay? So 802.11n uses WPA2, which is the encryption for wireless. And in WPA2, you can select AES, right? Different cryptography algorithms. So AES is implemented widely for all wireless devices now, smartphones, different things. So you can select. So when you do your hands-on project, you're going to see that. Okay. So here we are, right? You would have a distributed system, and that distributed system would connect to the access point through a switch, right? And then all your wireless clients. Sarah asks, can something like that be possible to put one up on the telephone pole far from the street and back at one's private property, and then sometimes sit in the car and get your information? Yes. Oh, the Wi-Fi pineapple. Yes. Yes. But it needs to have power. So if they put it up on a pole to scan your network, like they likely would have to supply it battery. And I have turned it on and left it on for at least a day and a half. So they would occasionally have to replace the battery. Like I would say every other day if it's on 24/7, and if it's constantly scanning, even less. So check your surveillance camera, okay? And then you might see, you know, activities. Yes, a person that pretend to be an employee, sometimes they could be sitting in their car. Also, I would recommend, like if that pole is really far, you can probably look at signal jammers. There are signal jammers that you can look into. Okay, fight signal with signal. So, or put something for interference. Okay. So if it's not their employee, then, you know, or it could be the former employee, so we don't know. Okay. Any questions? So we're gonna try to finish this, and then we are gonna take a break, and then I'll talk about your lab and your project, and then we'll be done. Okay. So let me see if there's any other questions with chat. So with the ad hoc network, you would see that there would be 2 computers connecting wirelessly, and or 2 of the similar system using wireless adapter connection. Like I mentioned to you before, like an iPhone with the smart TV. I have connected my Samsung phone to a smart TV to test. Very slow, right? Depending on the service. So when you do that, you're using IBSS. So it would be a set of service for those systems to communicate. And the way that we would do this is once you have the wireless adapter installed, you simply just have it set to an ad hoc setting. And many devices use its own app or controller now. So on the Windows system, right, you can go and change your adapter settings to connect to another. We don't really do this now. It's better to use distributed system versus, even on a home scale. So that way you can monitor it better. Okay. It says Mark is installing a wireless network for a home business or a small business. Consists of an access point, a small business server, laptops, wireless printer. What type of wireless network is Mark installing? And that would be in infrastructure mode because we have the access point connecting to many different hosts. So that would be in infrastructure mode. Okay. Any question? Okay. So let's talk about ESS. So like I said, right, this is another way that we can also control a wireless network is to not broadcast SSID. So Sarah, if all your devices are already connected at home and you don't have any new devices to add to the wireless network, change your SSID and disable it from broadcasting. So that way other people cannot see the identifier of your AP, your router. Okay? Any question?
Oh, I found $1.
That's what I said. I want mine. And I probably would have heard of it.
She said no.
Money bar, but-
How would you know if you can scan the QR code on your iPad to access the router? Is that just like an app?
It's just an app for the iPad to, or any device to because what that is just it uses the pre-shared key. You know how on your router it has, on your router sometimes it has a QR sticker, and that sticker just have pre-shared key, your security key information. If you change that, even if they scan it, they cannot have your pre-shared key. Okay?
Oh, okay.
Yeah. Yeah, so go into the router and change the security key. Save it, and then you have to change it for the rest of the devices, of course. But once that's done, you don't have to worry about it. Okay? Now, if you reset that router, it goes back to manufacturer setting, which has the old pre-shared key. Okay? All right. So let's talk about wireless signal. So here is my 2 access point for this company in the same department. You have 1 on channel 1 and 1 on channel 6. You have clients on both of them. Okay, so you notice that they have the overlapping signal right here. So when we physically install this, we gotta make sure that it's overlapping at least 10 or more %. Okay, so that way when someone is standing in the middle right here, they're able to see signal from both sides. Okay, so now because the SID, it's only going to broadcast it, the signal is only going to show up to a certain range, and then it's going to end, right? So we want to pick that up and then be able to repeat it for coverage. So to answer the next question, for number 20, we want to make sure that all access points should have an overlapping signal of 10% or higher when you're connecting them. And you would use the overlapping channels 1, 6, or 11. Earlier we talked about why we would use 11 when we already have one that's half a 1, right? So the answer for that is the bottom of page 10 going into page 11. The next part, we're going to talk about wireless controller. You're welcome. So wireless controller, what you can do is you can have a specific system to control, right, your WLAN, okay? So they can use a controller-based system to manage all the access points. Now in the standalone environment, if we don't have it control, you have to configure each individual access point. That can be very tedious. Okay, so they would use an appliance or a system that would control all the access point all at once. And this is more of a managed environment. This one, so let's say that I have a small company, I added one access point, I configure it, right? Let's say for one department, and I don't want them to share resources with the other one, then I configure a second one that's separate. So each of them is going to see itself as a separate network in that entire network. If we want to isolate access and data access and control, right, we would do a standalone. But it's very time consuming and it takes a lot of resources. So we often see that that will be more distributed environment is to have a controller. So to answer the next question, number 21, what's the main difference between wireless standalone and control-based wireless network? How are they configured? So the standalone controller does not have a full operating system. They are managed independently or individually. The control-based system has full operating system, usually, you know, a computer, a system that has the OS. And it's configured to manage all the other access points. Okay? Question. Most of all our wireless devices now are smart devices, so usually they would run Linux in the back or some kind of iOS in the back. You can use it to manage. Okay, so let's talk real quick about degradation of signal. So for the previous question, you can find that on page 11. Here it shows you what a mobile hotspot look like. So you're really using a way to establish an ad hoc and then move it up to more of a infrastructure if you're connecting many devices. So some of the things we need to consider: distance, we touched on that earlier, wall or other barriers. So if you have a brick wall around the facility, right, you would also have less of signal that's transmitting outside of the facility that is. So in some cases, company would purposely put some kind of wall, right? You would see government agency would do that. They would have some kind of wall protecting the vicinity, or some kind of ways to prevent signal from crossing that barrier. You can also use a specific protocol. So protocol has an impact. So some of the earlier standard can also have less of a signal. We can have interference, other electronic devices, cell phones, other wireless networks, Bluetooth, cordless phone, etc. So these are the things that needs to be considered. So what are the impacting factor in your wireless signal degradation is going to be distance, walls, protocol limitation, and interference. Okay. So I want to share this with you, even though I didn't put it on the question, so you know what they are. So for Internet of Things, like, you know, I had a question about Google Nest earlier, which use wireless, but you have other devices that use different technology wirelessly. So Z-Wave is often found with home automation. You find this in thermostat and appliances, refrigeration, stove, oven, there's lighting control, so many different things. So with the smart home, you often see, like if you're using electronic locks that uses Z-Wave, things for your garage door. Then you have AMP Plus. This is often used in medical devices and also in vehicle, or sometime, you know, used for indoor-outdoor lighting system, television, and it's governed and owned by Garmin. So Garmin implemented this for their tracking systems, their roadmap systems, and they have implemented the sensor in different type of devices. So if you're wearing a Garmin smart watch or smart wristband, you likely using ANT Plus. Okay. Then most of our other IoT devices uses Bluetooth or NFC. You see this for payment system at the sales terminal, like when you're using Apple Pay or Samsung Pay, those things uses NFC. Infrared, we see this in temperature scanner, heat camera, like, you know, if you have surveillance system that can see, that has night vision, it also had infrared capability. And then RFID is used for tracking assets. So stores, they use this with smart tags, so they know if where the items are placed and if it's lost or stolen. So you would see this in library and stores and different part of retailing world as well. Okay. And the last part, I want to touch on this when we talk about our hands-on project part 2. Okay, so I'm going to give you about 15 minutes break and then come back at 2:15. Okay, let's take a break.
I have a question.
Yes, Matt.
I'm looking to upgrade my internet at home, and I was wondering if I would have to go through maybe an upgrade service provider or a router. What do you think would be the best option?
So who do you have as service provider to start?
I have AT&T Uverse. We've had it since we started. We've had that one for years.
So do you use their modem or their router?
Yes, we have the router modem.
Yeah, so you can simply contact them and they should send you the new one. What because you already paid for that lease. After a few years, you technically own the one that you currently have. So usually they don't want that back because if they upgraded the technology, so I would contact the provider and have them send you a new one. And most of the time they would do that at no cost. Because if you had it for years, likely that you don't have, is it an AC, do you know?
I'm not sure. I'll have to
Okay.
check.
Yeah, so likely that you might have the older standard, which is slower in speed. And as you upgrade your home devices like your smartphone and your TV, you will likely see that you're not transferring at the speed where all these devices are capable of. So I would ask them to send you a new router or a new modem. Now, if you want to buy your own, if you visit AT&T website, they would have a list of approved router that you can buy in store. And sometimes it's probably right out cheaper to own them, even though they can be in the 100 something dollars. Because if you're paying monthly to lease the device as part of your service package, sometimes that would be $10-15. But if they don't charge you for the lease, then you can ask them also to give you a new one, and then you simply plug it in.
Sounds good. Thank you very much.
You're welcome. So I would do that first. And then if you want to buy your own, look at the list and then get the new AC, which gives you higher throughput. You're welcome.
Thank you.
Any other questions? Okay. So we'll finish the last question. If you missed 21 and 22, that's there. I saw some of you put that in the chat already. For 23, when installing wireless network, what should you consider when doing site survey? So this is the last question for our assignment. And you can find out more about site survey. Hold on, sorry for the whiplash. On page 13. So site survey is simply just for us to gather information about what we need in that network. So we have to think about the scope of the network, what we're doing there, what kind of data is used, how much data is used. Okay, so the best way to do this if you're installing it for a new business is to ask questions and also look at the area physically. Second, we need to look at the location because we have to see if there are walls. We have to see how far are there cubicles or their offices. In the case of warehouse, we want to measure the distance right? The length of the warehouse and the width of the warehouse to really see how many access points we're going to put in. And back in the day when I teach wireless, we would use some kind of signal reader. And when you station an access point, it would read to that boundary of that access point, and then you would put another access point to overlap it. So, but now you have your smartphone for that, right? So you turn on the access point, connect it to your smartphone, and then be able to read the signal. So at home, if you want to, you think about getting a signal extender, think about how you would be able to use your signal extender to check, to give signal to all the devices, and you would use a smart device like your smartphone to read the signal. To see where it's weak, that's where you would put the extender. And then you need to look at the type of devices that are connecting, like your laptops, your iPads, your iPhones, barcode reader. Okay. So many companies in the enterprise scales, they use all different types of devices. So we gotta make sure that they're compatible, and the speed that they use, the type of encryption that we use. So the stages for this is the pre-deployment is when you're looking at access point that's live and measuring the optimal distance, like I said. Okay, the placement of your access point physically is important. The second stage is to verify to see if all the devices are connecting appropriately. So there are two stages in that. So when you do this, turn on the access point, look at the signal and where they would physically be placed. And normally we would mount them near the ceiling. So you would see this when you walk into a facility, look up, right? You would see that they are mounted in the ceiling somewhere, or they could be hidden in the corner. And they can use specific antenna to really aim at a certain area of the facility. So we can do that as well. And then the second part is just to verify. So for 23, before installing any wireless network, what you should consider doing site survey would include your network scope, meaning how much data, what kind of data. Also the type of devices that are connecting in the network and their compatibility. And then lastly, we should consider the expected capacity. So if I'm expected to transfer at 1 gigabit per second, I want to be able to test that and confirm that when I do site survey. Okay. Often that you would see that technicians are hired to maintain and upgrade networks, right, with the company. Unless you work as a site contractor, you might see new businesses opening, then you would have to do the complete site survey, where you would start building the network from ground up. Okay. So sometimes service technicians are in charge of different things. And when you work with a new network, this is what you would do. With the existing network, let's say that they wanted to add a wireless network, then you would do that as well. You would think about where you would place the access point, see how the signals are overlapping, the type of data that would be transmitted using those access points, and the compatibility of all the devices. Any question with the last question in the assignment?
Hmm. If say I wanted to have my wireless connection 500 feet away from the house,
Uh-huh.
how would I know if the AP or the Wi-Fi extender or repeater can handle such a distance?
So before you place it, use your smartphone, connect your smartphone directly to that device. You can also use your laptop, but smartphone has at the top, it shows the signal bar, right? So what you do is you have to go as far as you can to the distance until you get up to the lowest bar. At that lowest bar is where your extender should be, or even right before that. Okay.
Okay.
Yeah, so I would say for AC router with even built-in extender, you're gonna probably be best to do it about 200 feet. Even it depends on the router. So some extender works better than other. So you would have to manually check it because the router itself doesn't tell you very much. You have to use other device to read the signal. So now, not considering other factor like trees, right? And things that could be line to sight that's blocking, walls, fence, things that are reflecting the signal. So in the case where you have, like, if it's locating near waterways, that could be also an other interference. So if they have other electronics in the surrounding area, that would also cause signal to degrade. So when we say distance-wise, it's just approximate. You have to really read the signal to really place it accordingly. And I hope that helps.
Yeah, I was just playing around with the idea of putting an extender in the backyard since the park is maybe 500 feet away, and being able to use my home Wi-Fi at the park.
Yeah, you can do that, but you have to also know that there are other networks in between you and the park. So you're gonna have, and they are operating on the same frequency, right? Like how you pick up your neighbors or other people's network. So you do have some of the interference from the other networks. So ideally, if we have nothing surrounding, yeah, you will be able to pick up pretty far. And for security reasons, you would turn it on when you use it, and then you turn it off when you don't use it. I would do that, okay? Because people are curious and they try to get on your network. So just for security reasons. Okay. You also, they also have mobile extender. I've tried a couple of them. They're battery operated. They're not the best. So sometime you can check out some of the reviews and the available of the certain technology. So you do have some of those. But, you know, using another wireless router like what I had to extend it, you just bridge it and make it a second one. So you just connect to it and then it connects to your main wireless router. Okay. All right. Other questions?
Yeah, I do have a question.
Yes, Daniel.
So for looking at routers, when you see AC on it, I mean, you know, you got like your 2100s and then your 1200s. what is that a big factor of looking at purchasing a router?
From a consumer standpoint, for home use, not so much. But when you're scaling for enterprises, yes. And you know, the higher end model, they tend to be in the $400 or $500 or even more for enterprise use. But for home use, optimal speed doesn't always mean we operate at optimal speed, you see. So I don't see a huge difference for, you know, small scale use. But when you're looking at like large amount of data being transmitted, yes, that does make a huge difference in throughput. So what Daniel is asking is, when you're looking at AC router, sometimes they would indicate the type of speed. Like for example, this one, Netgear is very common, right? And they would tell you, and manufacturer would try to tell you, use a model indicated with the standard. And if we compare this at $130 to the Nighthawk dual band, which is also AC, right? And it's at 2,300. So if you have like 6 gaming systems are running simultaneously, you do see a difference. If you have a lot of data being transmitted, if you're streaming a lot of things, yes, you would consider this as a factor and would invest in a higher quality one from the same manufacturer. Okay. And then when you look at the AC2600, yes, if we're using a lot of streaming media, I would invest a little bit more into it. If it's only like, if it's less than $100 difference, in the long run, when you add more smart devices, yes, it does. But if I'm just simply using things for internet, check email, so if you have 6 people that are on Zoom at the same time at home because of COVID-19, yeah, the upgrade of this will be helpful. But if you just have, you know, in my case, my husband and I, we sometime would be on Zoom at the same time, sometime not, right? And we stream periodically on some nights when we watch Netflix or something, or when he watched football or soccer, then, you know, it's not a huge difference for me. But so consider the case, Daniel, like how you use it. Okay.
I got one more, sorry.
That's okay.
So,
No problem.
as far as like comparing, I guess like the mesh versus an extender, because there's some routers that you can have like a mesh node to, you know, put to it. What's the
Yes.
difference between the two?
So mesh is gonna give you a little bit more capability with ad hoc and also some controller with that. The way it's designed is to work with other type of protocols. So when you're looking at like the Google devices, they design it to work mainly with IoT, and IoT has many different set of protocols for services. So you do have the capability in that, where extender, you can just extend it and it's mainly going to operate on the 802.11 umbrella. And you're not going to be able to have more of, you know, different services that's incorporated. So you do see some higher price range in some of the mesh technology, like $400 compared to $250 or $200 or less. Okay.
Thank you.
You're welcome. And you know, 2 years from now, we're gonna look back and everything is probably gonna be lower. So I would say if you are considering implementing more of like a mesh network, you want to kind of slowly upgrade it and carefully research the technology, because, you know, once things get stabilized, they usually mass produce it. So you often see the price drop as more supply versus demand. Okay. Other questions? If we get the gaming router like the Netgear Nighthawk, does the modem have to be upgraded? If your modem is at AC, and what I would do is I would test your speed for the modem. If it's an older modem, yes, you should contact your service provider and have them give you a newer modem. And normally they would replace it between 3 to 5 years. So if you have it for, let's say, more than 3 years, I would ask them to replace it, Eunice. Okay. Other questions? That's a good question that I want to share with everybody. So, okay. So let's touch on what we need to do for our project.
Oh, there's another question in the chat.
Oh, okay. Let me, because when I'm in screen share, it doesn't always pop up. Let's see, all the devices connected to a particular. Is there a way to download a VPN to the modem so that it automatically will apply to all the devices that connect to that particular router? You can set up VPN mode on the router itself and connect the other devices under the VPN mode. But you don't necessarily need a VPN application for every single device. You can use the router to control the virtual private network, which is VPN. And when you do that, other people don't see your traffic, but you have to specifically configure those devices to connect to the router under that VPN mode. So as we get, I'll show you what that looks like. You're welcome. Okay, so I added, so instead of having you guys tweak your stuff at home, I want you to use an emulator, which is a software that they release for all different types of routers and extender. You can play with the other ones before you start attempting it, so that way you don't mess up anything at home first, right? We wanted to look at the configuration and what it would look like, and then test it and then use it for home application. Okay, so in the project part 2 for this class, I found a website that offers the emulator. So let me open that up. No, why is it doing that? Okay, so on this website, you would see these are just software or the interface that they incorporate with different routers. And before you buy your router, you want to see how easy it is to configure. This would be a place to look at that. Okay, so in project part 2, I have you visit that site. And I chose one, which is Linksys, but you can check out the other. So for example, right, if we wanted to look at like the ASUS AC, it would look like this for the interface. So before we get here, what you would do is you would open up a browser window and then you would type in the router address. You know, like a .1.0, whatever your router address would be. And it will prompt you the login before it opens up this. Okay. Now every interface is going to look slightly different even with the same brand. So on the AC, you often see that it would have some information about the band, the dual band. It would also have some authentication information. The other ones too, but it it has the newer authentication method. We would always want to use WPA2 with the encryption for the encryption mode, and also the type of algorithm. The latest you would likely use is AES, and it works. That's the standard that would use for most of our technology that all the devices are connecting. Now, when you're using WPA2, you would often see the pre-share key. That's your security key number that it could be on the sticker of the router, but you should change that. And you need to use a longer length key so that way it's harder to break. Okay. So the pre-share key is more for convenience, where we would only use that one key for all the devices. But when you change your authentication mode to enterprise level, every device would have to have a different way to authenticate. And normally we would do this to manage it for authentication, would use a server. Okay. So in a business like Moreno Valley College, they would use enterprise mode. Okay. Question? Okay, so some interfaces are better than the others. So let me go back and I'm gonna go ahead and select Linksys all. And you would see different type of Linksys, right? And then I have you select CG7500. And they eventually always release new firmware. So one of the things that you should also update on all your smart devices and all your IoT devices is the firmware. It addresses security issues, especially with smart TV. It also addresses interface problem and response to the software. So this is the version that they release. So once I open the browser window, put in the IP address, I would see a login screen. Okay, it would look like this. And by default, most of the time when you use a Linksys device, you would see the password information on the package or inside the package or on their website, but it would likely use admin. Admin for username and admin for password. When you look at this, it never really show it based on the character value. They just use this to show the default. Now, when I look at this, I would know that this device right here had parental control. So if you have kids and you don't want them to access the internet after a certain hour because you want them to get off the computer or the tablet and maybe eat dinner or spend some time with family or doing homework, you can implement parental control. This just allows us to block internet access for that device. Okay, I had to do this when my brother was growing up, helping my parents, because he still games a lot. It's just, you know, it's a way that we can control internet access. So I did this for my brother's computer, similarly to this. So you can specify the days where you want to have control for internet access. Okay, the time even. So on the interface, if we click parental control here, we would see that we can manage it, right? You can put in the MAC address of that system, and then you can specify the time and then apply. Okay, and that's one way that you can control traffic. So in the system status, it mainly just tells you the uptime, the router uptime. And under the system information, it gives you the general information about that router, okay? Such as your public address, which is your WAN. That's a public address that's outside of our network. And then your local address, which is the LAN. Okay, and often it would use this class address because for our scale, we don't need a larger set of address compared to for the IP version 4, if we use class A, that would give us more devices. But you would often see that out of the box, it would use this. Now, most of the devices are shipped with the UTC, Universal Time, but you can specify the type of time for your zone. On the Wi-Fi option, this is where you can specify your band. Because we enable dual band for the AC, we would see 2.4 or 5 gigahertz. And this one, we would have it on auto so it can switch back and forth or have selection based on the device that's connecting. So I'm on my laptop and I'm connecting 5G so I can zoom and do other things on the internet at the same time. But for our other systems, I have put them on 2.4. Like for example, if you have surveillance camera, they often are on 2.4. Okay. And if you have older devices, you want to have mixed mode. And what that means is that it works with all the older standard. Okay. So you can enable specific band and then you can have them auto or you can specify. Now here we would have Wi-Fi password information. If you enable guests, so in the case Michelle asked me earlier, when I extend that, well, what you can do is you can have your device connecting to that extender, and that extender is connecting to a guest password, and then you can disable the guest password when you don't use the network when you don't use it. Okay. Now you can limit the number of guests that's on. So let's say that you have a business and for that business, you have an open house day where you would invite other people and other business to come. Well, you can turn on that guest network and then you can enable the number of guests on it. And then when you're done, you would disable that guest network. So we can turn it on for that day. And then when you click the Wi-Fi clients here, it tells you which system are connected. So going back to Sarah and Michelle's question earlier, how do you know who's on your network? If it doesn't show it on the network map, you can also check it under the Wi-Fi clients. Your router should have the capability to look at all the systems that are connected to it. Okay. And we can also remove certain client as well. Okay. And it tells you which channel they're on because the routers is very clear. So on this one, I know that this is an older, the transfer rate, I can tell that's an older standard, right? And it's using specific channel because we have the channel on auto. So that way we can have it mixed mode, and this is an older one. It's the frequency is lower. Okay. And then as you see with the 5G, it has higher frequency bandwidth. So what I want you to do in part 2 is check out different tabs and be familiarized with it. And this is why I'm explaining it now. Okay. So that's the Wi-Fi information on the left. Quick start is just generally on how to connect. But let's look at configuration. So this is where you would change your system settings or your router settings. So I tell people that you should change your SSID to your network because A lot of the times we would say what that business is or what it is, right? And out of the box, when you plug things in, it's what the manufacturer has programmed it to be default. So now if you don't want that to broadcast, if you don't want anybody to see, right, what that router is, you just simply disable that. Uncheck it. This mode, network mode, allows us to connect to specific 802.11 standard. So if you have older technologies at home, we would have it mixed. So that way the older devices can connect. The bandwidth, we can have it on auto or we can specify which ones, and also the channel. So as we talked about the channel here, right, you know that some are overlapping and some are not. So if your router has it on auto, it automatically puts the appropriate channel based on the standard. So often we would find it as auto. Encryption and security mode. This is how people authenticate when you connect your device. Like I said, WPA2 is available with all the current releases of router. We are transitioning to WPA3. And WPA3 is way better in such that it's using, you know, different encryption. However, it's not fully implemented and they're still working out some of the issues with that. So when you buy a brand new router now, you might see WPA3, okay? But the WPA2 is what we should be using. And at home, you would have the personal. At a business, you would have an enterprise, sometime a mix. Okay. Here is the passkey or password. I don't say password anymore because usually it's just key. So this is for the 2.4 gigs and the 5 gigs you also can specify. So yes, I can have different passwords for different band. Okay, I can have different names, of course, for different band, and by default, it should say 5G. Any question with this? So now when you configure your router at home, or when you go in and look at it, you can see what everything is and know what it needs. Okay. Some of the things that you should be doing is to MAC filter. MAC addresses pertain to the physical system, right? That's the physical address, and we learned that during the first week. What we can do is we can specify which system is allowed. You can add that to the allow access, or which system do you want to block. If you have a neighbor that knows your pre-shared key to your router, and if you know and you find that system, you can block them. Okay? You can only allow the systems that are connected. So if you know somebody is entering your home, let's say a visitor, and they're trying to connect, if they're not on that list, it will not connect, even if they know the key. Okay, so MAC filtering is a powerful tool that we use in security, and we can use it to track our system. You can also manage guest access if you enable the guest network. And then advanced settings here, this one allows you to do site survey with it and then looking at the Wi-Fi client.
I have a question.
Sure.
So for the MAC filtering, if you enable guests, you know, that guest Wi-Fi, do they have to be on that MAC filter list in order for them to connect?
No, because usually the guest Wi-Fi, you can have it in different mode. Let me see. Yeah, you can have it completely open. You can have a share key for just that Wi-Fi. that guest Wi-Fi. So it depends on how you set it, but no. So the answer for that is they make it where it's convenient just for that guest Wi-Fi. What you specify is what you're gonna use. So most likely we don't have to filter on that. Okay.
One more question too. I also have a Linksys too,
Mm-hmm.
and I realize when I do enable the guest Wi-Fi, because I don't have mine broadcasting at all, but when I enable the guest Wi-Fi, it does ask me to broadcast one of the networks, like the 2.4.
Right. The guest network.
Correct.
Because the guest network is designed to host guests, to get things connected to it. So it has to advertise itself to everybody else.
Correct. So what I'm saying is, because I don't have like my other networks broadcasting, it wouldn't broadcast the guest Wi-Fi unless the 2.4 is enabled.
Yeah, because it's using the same band and the same channel. Yeah,
Okay.
so
I
you
can't
have,
hide it.
yeah, you can't hide the other one without it. You can hide the 5G, which is a different band and a different channel, right?
Okay.
Yeah, so if you disable the SSID on the 2.4 and you enable the guest, it won't allow you, it would want to enable the SSID, because the guest, even though it has a different name, it's still identified to that band and that channel. So yeah, unfortunately they don't have it where it, now if you set it, maybe you can tweak the channel, but I think it's still gonna be on that band, so it won't let you, the way they designed it.
Thank you.
You're welcome. Other question? So as some of you are on it now looking at it, right, it is a little slow to respond, so I'm just gonna explain it using the other one. So this one you see a little bit different. So earlier, going back to Sarah's question about VPN, okay? So, and I can't go in depth with this for the sake of time, and we will save that for the next class. But the type of VPN you select is gonna be the service that you're gonna get. A lot of the times you would see OpenVPN being used for web, like if you're using a web services virtual private network, like if you pay, I don't know, $50 a year, and you would connect to a website, and that website would connect you to a different communication pathway. So you would see that here. Now the point-to-point, the Pptp is really designed to connect one system with another through virtually as a private network. So if you wanted to set up where, you know, if you are transmitting data, if you want to have a safe communication between your laptop and your game desktop, you can do that. Now on the Ipsec, this is often used with more on the business scale as well, but you can set it up. What it does is it creates a tunnel for the transmission, and it's piggyback on the IP, but it has the security component, hence the name Ipsec. So now it says right here that the wireless router currently uses the private WAN, which is this. You have to port forward it when you try to set it up. So it would use a different number to really send that out. And you have to be able to enable it for the other devices. So it depends on what type of mode that you're using, okay? So if you enable this router to become your Pptp, it tells you on how to set up your pool of addresses. So I would add the client that I want on a virtual private network. Let's say all your devices inside your home. And you know that the Pptp, you need to know that it's limited. Usually they would keep it under 10, okay? Because, you know, the whole point to that is just going to be a point-to-point connection, so it won't dynamically scale. So this is, we can turn the router on and make it a VPN server and connect it that way. So that way it would seal the traffic information to the other systems. And it walks you through on how to configure it. So a lot of the times, if you don't have that information inside the router, look at the online manual or instruction from that service provider. So a good router is one that would give you the VPN capability. Now, if your service provider router doesn't offer that, what you can do is you can get an extender and use that extender to connect to all the devices and funnel that through and set it up where, you know, you bridge it, and then you can set up the VPN that way. It does get a little bit of a bottleneck though, right? Because it has to go through that extender. However, if you consider security, then you can do it that way. Okay, any question? Okay, so on this one, it does have the traffic analyzer. It gives you the statistic for, you know, when you have peak and when you have slow. And, you know, there are other functionality for the air protection that goes back to security and parental control on this one. Okay, so as you see, some wireless router has a little bit more configuration interface, and we talked about the bandwidth and such. Okay, and then with this one, you can have it set up with Alexa, and then specify on how your Alexa would respond for smart home. Okay, and then this one has the air mesh capability. So if you have a lot of smart devices, you can control the smart devices and the way it treats it as subtopology in the network. Okay, and you can, and it specify like the wired and the wireless for the client list. So you can also add a node to that, right? Like if you're using another mesh node, you can add it to it. Okay, question? Okay, so the USB application, I'll show you that real quick. So we can use USB to transfer connection configuration. We can have it where we can make our USB to become, you know, like a disk to share files like photos and video. So more of like a network storage. You can make this where it would be a server center, especially like a media server center for or file transfer. So you can make it that way. You can set it up. And with this router, you can have it where it becomes a server for your print. So it store all your print queues, and it allows you to control your network printer, especially if you're sharing that printer with everybody inside the network. And then on this one, you can make it as a modem for 3G and 4G mode, like a dongle. That's what we used to use that before to connect to things that can't connect to cellular. So I rarely see this being used now anymore because we have the larger Wi-Fi that's much faster, but in the case that you need it, you can turn it into a dongle. You can make it into a time machine. If you're familiar with Mac OS, you know what time machine is. It's really a way for backup. And then you can make it where you can download, manage. So if you have a lot of people downloading, you can actually control the download. So it treats it as a temporary storage, and you can manage what comes through as download. But some other routers don't have that capability. Their USB simply is a way to back up the router information and to share files only. So depending on one router to another. Okay, question? All right, so I want you to check out the interface so you're familiar with that. Leaving this class, I don't want you to have any questions about what is this, what is that, right? Now is the opportunity to ask. If you see this QoS, especially on a network management level, QoS stands for quality of service. And we can actually see, right, like the speed that's coming through. And in network management, we care about 99.99% availability and throughput. So you kind of see the scale of, it might not be like this, it might give you a log or a graph of our transfer for all our systems. Okay. Any question? Okay. Yeah. So what Apple Time Machine is, yeah, it's used to store the setting, the configuration, the image of your system at a certain time period, so you can revert it back to that. But so similarly, you would have some time machine in this where you can back up your configuration and your settings to the storage and then use it, you know, in case you change something and you don't want, you can revert back to that. Okay. All right. Any questions? Oh, you guys like networking. You have a lot of questions about networking. That's good because I want you to be able to apply it, right? You can turn on the web history for this. This is great because it actually tracks the web serving history. So if you wanted to check to see if certain person is on, right? Some router has this capability. So it caches the web browser, and that could be a long list, or it would generate a log. So when I turn this on, right, and then it would, because Trend Micro, you have to agree or disagree, so you know, you get the point. Okay.
Question.
Yes.
So I'm new to like taking things apart, and you know, I see all these old routers like at the used stores. Is there anything that I can do with like a really old router and taking it apart?
Usually it would have a board. It you know, you would see some RAM component either on the board itself. Some of the more expensive one, they would have their own RAM. It won't have any kind of drives or anything. So usually those chips are soldered. What I would do with the old router is to play with it, to plug it in if it still works. But if you want to take it apart, you can probably make it into some kind of scanner. There are tutorial video on how to tweak things and make things into scanner because the router itself is, it scans.
Oh, good to know.
Okay, yep. People are very creative. There are ways that you can scan a lot of different things by tweaking devices. So it makes you a hacker. Just hacking devices, changing it. Okay. All right. Are we okay with this? Any question as far as looking at your router configuration? So I use an emulator just to let you know that, because if I connect directly to it, it would take me off Zoom. I could use a second laptop, but you're not gonna get, you know, the whole ordeal where I have to switch back and forth. So that way you can check out different interface and see, possibly look for something that you might want to purchase, or, you know, if they have it. Okay, so for project part 2, look through the interface and then, you know, see if you can change it up, answer the questions, take the screenshot and paste it into the document, and then all you do is submit it. And then when you want to go into your router, you can start playing with your own router, configure it, create a MAC IP MAC filter list. Some router will give you an IP filter list. MAC is a better list to block and allow access. Okay. All right. Is there a question on project part 2? This is due next Saturday, so you have the whole week to work on this and look at the interface, okay? And next week is our last week of this class. It went by so fast, blink of an eye. Next, I'm gonna talk about the lab. Okay, so question, I have an old Cisco PIX 501 firewall, SSH version. What can I do to tweak it? Have you tried terminal into it? So I would recommend, Michelle, is to, if you still want to use it and learn how to use it, PIX is good. If it's still working, you can use Secure Shell to connect. And this is to share with everybody, just to answer a question.
But it's SSH version 1, which is not secure.
So you can test it. You won't be able to use it in your network, but you can learn to configure it. So
Okay.
to get to the terminal, you have to use something like, okay, so there's a way that we can interface with the switches and the appliances in the network and for security. And you can use Secure Shell and SSH for everybody, right? If you don't know what that is, it's a way that we can connect, and it depends on the version, like she mentioned. Some are better than other in secure wise. So, and I'm surprised that RCC hasn't taught you guys this yet. Because when I teach networking, I always have my student SSH into their appliances.
Oh no,
So,
I have learned that. I just don't know
okay.
about the PIX firewall.
So PIX is great. PIX is cool. It's a good firewall version that Cisco made. So you would use PuTTY, and then you would connect to it, right? Look up its information or the manual. And then I would terminal it in, and I would be able to enable screening, filtering on the firewall. You can filter specific systems. So that's a good way to get more practice. As far as appliance go, if it's older, see if you can upgrade firmware and you can maybe implement it for internal network. Doesn't always mean that the old SSH is not upgradable. So
oh no,
if
it has end of life already, like 2004.
Okay. So yeah, then I would use it for practice. That's what I would recommend, because if you know how to use PIX firewall, you don't know how many employers contacted me because I put that on my resume since like maybe a year or two into the field. Until today, there's still people trying to contact me for PIX configuration because people don't upgrade. Okay.
That's scary.
Yeah, they have new firewall. A lot of networks don't upgrade because they don't want to spend the money. Okay, so let's talk about the lab, and then I'll give you time to work on the lab. Sorry, click on the wrong one here. module. So in this lab, we are going to use practice lab again, and I want you to be able to look at Windows network configurations. So last week we saw some of that already. So just to briefly give you the lab, this lab should only take you an hour, and again you're going to use Windows 10. Okay, so there are other virtual machines here, so make sure that we turn on Windows 10. And then we are going to reconfigure the network binding. So here it tells you that network binding is a way that we can establish connection with specific protocol. And for the Windows and Linux, we would use TCP/IP. The older Apple uses AppleTalk. So in control panel, what you're going to do is you are going to again select network and internet, similar to what you did last week, and then you're going to look at your network status. Okay, let me see if I have my Windows 10 up now. It says it's busy, so this time of the day it might be a little slow. So once you have that, so in my case, right, I'm just going to illustrate it on my computer. So here is my control panel. This is the category view, and if you don't have this, you might have it as small icon for the list. So we would click on view network status and task, and this is where you would go in and look at your configuration. So as you can see, I'm on my Wi-Fi 5G, and then you can manage your configuration this way. Okay, so in this, what they have you do is, now my Windows 10's on so I can show you that. And once that's established, we simply just search for control panel. And when I teach Microsoft, I tell my students, in client desktop, control panel is your other best friend. You can do a lot to a system using control panel. Oh, well, it's a little buggy, slow. So we want to get into advanced setting for this. And like last week, you saw this, right? When you look at the properties, but in the advanced settings, you can take a look at a certain adapter details. So what they're gonna have you do is to select the binding. So uncheck the version 6 IP address, and then you're gonna select the local area bindings. And that's going to allow you to manage your file sharing and also your printer. And then they're going to have you verify the proxy setting. We talk about proxy server since week 1. Okay. And with proxy, we can use it for web caching. We can use it for firewall rules to filter. We can use it for authentication and also to record every single website. So earlier when you saw my ASUS router interface, where we can, when we enable that, that simply is a way that we can have it cache, right, your web browser information and account for it. So it keeps log of every single website that the users goes on. Now that might seem extreme, right? But in a network level, sometimes we block websites. We don't want people to access pornography while they're at work. We don't want people to gamble while they're at work. So we wanted to track internet history. And, you know, so the user actually waived their privacy when they signed a contract, when they signed an agreement with the company. And so when I teach forensic, I tell people everything is recoverable. in some scale. Okay, so if you really want to look at what they access, a lot of the times we just simply enable configuration, or we go back and look at the file. Okay, so in this, it shows you on how you can look at proxy settings for the system. Okay, I would demonstrate it, but it's so slow right now and it would take forever for me to click something. So I'd rather have you work on it. And so you would go and look at your LAN settings and then look at your proxy. So that was exercise, the end of exercise 1. Don't forget to take the screenshot when you get there. And then again, we are going to use Windows 10 for the second exercise. And we're going to look at the host file. So every time that you use something like www.google.com, when you type in that URL, what the system will do is we would connect through HTTP or HTTPS to request, and we would connect to the Google web server. Then the server would respond back. But with that, it needs to connect to part of their domain, which is their DNS. And it would take that and translate that to an IP address. So when a user connects to a network, a domain, right, it's either connecting with IP address or it's connecting with the domain name. And when we use the domain name, the server, the DNS, takes that and translate that to the IP address, and it would service that system. Then we can authenticate with the Windows network. We would use Active Directory and so forth. So what this will do is it's going to show you the host file from the DNS, the domain name server. And every DNS would have some form of host file. Now in security, we can do a lot with this host file, okay? From an attacker standpoint and also the protector standpoint. So it's kind of important to really see what that is, okay? And it's, as it is in text, you would use Notepad to open that up, okay? And you would see the host information, the server information, right? So if it's not concealed, it should allow you to look at the host file. In some cases, they would conceal that because we can do a lot with that. From, you know, to protect security, they would try to conceal some of the host file. Not everybody can access that, right? So here it shows you that this is the domain. Now, when you look at the domain practicelab.com right here, that's the domain name, okay? And under that domain, there is a child. So you can have a domain like bankofamerica.com, and then you can have a child of that domain, hq.bankofamerica.com. And then you can have a grandchildren from that child, right? Branch 1, hq, bankofamerica.com. So that's how you look at that. And then the DNS job is to tie the domain name to the domain server address. So in the text file, you're going to see that information. So from an attacker standpoint, they can definitely, if they get a hold of your host file, they can, once they're in the network, they can find out what is your DNS, or what its name is, what its address is, and then they'll target that. Or they'll use it to reconfigure and modify your network connectivity, okay? So here it shows you that, and then once you update the file, we have to update the cache for it, okay? Another way that we can do this is through ipconfig display DNS. Now, some router allows you to have DHCP, DNS, and other server capability. Okay, so if your router has the DNS enabled, it should also have a host file information. So you can obtain your DNS by doing display DNS. Then we're gonna ping. We talked about ping last week to see if it's alive, it's connected. If it replies, then it's connected. And then we can check the net usage for a specific system. This one is the DNS. So you would get, it would give you a system error at this point. Okay. So you can see the net use of that system. Let's see what other things I wanted to point out. So they're repeating some of the steps so that way you would know what. So in some cases, when users are connecting to a domain, and if that domain server has already been updated, or they're connecting to a different DNS and they're trying to connect to your DNS, then it has to flush the old DNS information that was cached in the system. So now, since when the domain server serves a system, it gives it that file saying that I'm the host, here's the file about me. Now, if you connect to a different DNS, what you need to do is your system needs to acquire a different host file. Then what we can do is we can flush the old one and get the new one to be stored. So this shows you in step 9 on how to flush DNS. And this is also a good way to troubleshoot if a certain system is not connecting to a certain domain. Okay? Like when you go to school and you're trying to connect to their network, right? If you authenticate to their network, likely that you're connecting to their servers. Or when you go to work, you often see that as well. So to look at the DNS server IP, we simply use ipconfig all. And sometimes they won't display this. So most network would give you the DNS information, some don't. Okay, for security reasons.
What is the best way to make sure you aren't DNS hacked? Like it changes it to a, you know, the IP address doesn't, they change the IP address that the DNS IP address is connected to?
The best way to do this on a business network level is to change your authentication and your encrypted communication channel. So that way they cannot authenticate if they don't have the proper resources. And also you need to control privileges. So there are multiple layers in that. And then on the authentication level, you have to make sure that when it handshakes for system to connect, it needs to make sure, because in order to join a domain, you have to authenticate. And when you set up authentication, you gotta make sure that it's at a secure level.
Okay.
Yeah, but you know, it doesn't always mean that we cannot get attacked, right? There's always threat. It's a matter of time. It's not about if it's going to happen. It's going to be about when it's going to happen, and that's the perspective. So what you have to do is you have to implement multiple layers, and also you need to monitor consistently. Okay, so that would be a job for security specialists and security manager. Okay, I'll come back to this, so let me finish this for everybody. So we ping We check to see if it's connected. We can also do NS lookup. So NS lookup would look up what part of the domain that system is, right? So you put in the system name, it basically it will tell you which domain is that system connected to. So we can use this to validate to see if it's in the proper domain or if it was joined to a domain. And then also, you know, from a security standpoint, they can do NS lookup to look up various systems who the DNS is. And if it's enabled and if it's enabled to show, it will tell you what the domain is and the address. Okay, so we can ping a system as part of that domain once that's joined. And they already have it joined before for you guys. Okay. So this kind of give you some information about how to use your command prompt. Now FQID is frequently so a full qualified domain name, and that often refers to the .com. So you would have practicelab.com, microsoft.com, google.com. Those are the fully qualified domain name. And that domain name is tied to an IP address. And for all the web servers that are out there, right, they're using public address, which is the WAN address. Your router would have a WAN address. So we can use the router for other functions, but be careful with that, right? It becomes a single point failure and other things. Okay. So we would check our DNS settings and your IP addresses. So in order to join the domain, your IP has to be part of that domain. It needs to be part of that subnet. So I cannot have like 10.10.0.8 and be able to join 192.168, whatever, without having a router. So in order to connect to a different domain or network, I have to have a router in the middle. And also to be part of the domain, you have to be part of that IP range. Okay, so we can't just simply join having different subnets and things without having a system that interfaces that. So here it shows you how to put in a static IP address where you can configure a certain address. And we would do that for like a network system where other system would rely on it, like a server. Okay, so it shows you on how you can set that up using Server 2016 is the operating system that they use. So at this point, you would use a different virtual machine, the Lab BDC01. See that? Okay. So you're configuring the server at this point. So that would be the end of exercise 2. Okay. So when I teach networks, sometimes I make them install server and configure the whole works. It, you know, if we have the 16 weeks, so that way they know how to do it. And there are different types of server OS. Okay. And along the last page is just lab assessment. So you go through and answer the questions and then submit your report and then click done. So two exercises or 2 things that's going to be on Windows 10, right? Looking at proxy settings, and then you're going to transition that to Windows 10 with host file for the DNS. And then lastly, you're going to work on using the server virtual machine to look at DNS configuration. And DNS is very common in business environment, you know, in all different scales. Okay, other questions? Okay, so in the last 30 minutes, I'm gonna get off Zoom and I'm gonna let you have time to work on the lab and your projects, okay? So don't forget, we have a quiz, we have a project part 2 that's due next week, and we have your lab that's due by next week. Next week, we're only gonna go over troubleshooting networks and some of the sub area we haven't talked about. We're gonna do an assignment and possibly do a game or a quiz, and then we'll be done with our class. Okay? All right. All right, I hope you have a wonderful Saturday, what's left of it. Work on your assignments, and if you have any question, please send me an email. Type in your name and enjoy your weekend. And then let's see. Is that from Sarah? So I'll answer your question now since I have time. I really learned. Let's see it already. I have an old phone. Good. BlackBerry GSM. Okay. Different brands. Yeah, so if you guys have old devices that you don't use, you can save it and then you can donate it to our lab. I have I teach CIS824B sometimes, or if you don't want to experiment anymore, you can take off the SIM, make sure you cut it up. You know, what you can do is you can donate them to me and I'll make sure it's zeroed out. If it's still working, if not, we'll make sure that we disable any kind of data read on it. You can donate it to us so that way when I teach like IoT and things like that, I can open it up and I can show them how the boards are designed and such. Okay. I will communicate with the library to see if they can drop it off there or a way that you can drop it off, but I'm occasionally popping on campus. So I'll let you know soon when I'm going to be on campus next, and so you can maybe bring it. But if not, you can hold on to it, and then they say that after December we might be able to go back. We're not sure yet. So, okay. Thank you, Sarah. Other questions? Okay, so enjoy your weekend. If you don't have any questions, I'll take other questions. I'm going to be on for a little bit. I'll stop the recording.